Okay, so we're going to talk about a new term here called a perpendicular bisector of a segment. But before we can look at a perpendicular bisector of a segment, we need to talk about just a bisector in general, bisector of a segment. So what is that? That is either a point or a segment or a ray or a line, any of those, that divides a segment into two congruent segments. So we can take a look at our diagram here. In this diagram, x is not only marked as the midpoint, we already know that term, x is the midpoint, but because it's a point that divides the segment into two congruent segments, point x is also the segment bisector, or the bisector of the segment. Or we could also say that point x bisects line segment AB. So there is what it looks like as a point, but a bisector could also be a line segment. So I could also have line segment YZ being the bisector. So it's a line segment that bisects that line segment, or in other words, that cuts the line segment into two congruent segments. So now segment AX is congruent to segment XB. Now, if I extend that a little bit and put an arrow just on one end, now we have ray YX being the bisector. Okay, it's still bisecting line segment AB. And lastly, if I extend just a little bit further with an arrow on that end, now we have a line YX, and now line YX is the segment bisector. It's bisecting segment AB. So that's what it looks like. That's just talking about bisector. And by the way, it didn't necessarily have to be, that line didn't have to be exactly vertical. It could have been a diagonal line, or line segment, or ray, or just the point alone. But there it's still dividing that line segment into two congruent segments. So that's a bisector. Now, if we want it to also be perpendicular, that makes it what's called a perpendicular bisector. So all of the things that we said up here, except for now, generally when we're talking about a perpendicular bisector, it's a line, or sometimes it could be a line segment, but generally it's a line. And it is not only bisecting segment AB, but it's also perpendicular to segment AB. So we could say, looking at this diagram here, that line RS is perpendicular to line segment AB, because it is a perpendicular bisector. I can see how from it's marked. And I can also see that segment AX is congruent to segment XB. So we have this line RS being perpendicular, but also bisecting line segment AB. So we do have line RS is a perpendicular bisector. So when we're talking about perpendicular bisector, we're referring to line RS. Line RS is the perpendicular bisector of the segment AB. So now that we know what a perpendicular bisector is, let's take a look at how we could use this information. So sometimes we'll be asked to write an equation of a perpendicular bisector that goes through a line segment. So this is the same diagram we had a moment ago, and I'm just going to think of that diagram while I'm looking at this problem. I'm going to visualize that. So if A is 2, 1, and B is 6, -3, then line RS is the perpendicular bisector of line segment AB. So what we need to do is we're supposed to, in this question, it's asking to write the equation of the perpendicular bisector. So remember, line RS is the perpendicular bisector. So in other words, I want to find the equation of this line, line RS. So the first thing that I'm noticing is that line RS is in the middle of line segment AB. So we already talked about earlier how to find the midpoint, and that's where we're going to start. We're going to find the midpoint of line segment AB. So let's go ahead and do that. Remember, to find the midpoint, we average the x values and we average the y values. So the midpoint is, let's start with the first x value of 2, and let's add the second x value and divide that by 2, and then do the same thing with the y's. So 1 plus -3, and we'll divide that by 2. So when I simplify that, I'm getting 8 over 2, and -3 plus 1 is -2 over 2. So that gives me 4 and -1. So now I have the midpoint, which the coordinates of the midpoint, which are 4, -1. So I could think of that as 4, -1 there, point x. So that's the midpoint, but I'm supposed to, remember, I'm supposed to find the equation for the line. So I'm going to have to figure out the slope of the line segment. Okay, line segments can have slopes too, so that I can then figure out the slope of line RS because it's perpendicular to line segment AB. So let's go ahead and find the slope of line segment AB. So M is going to be change in y, so -3 minus 1 divided by change in x, which is 6 minus 2. So that's -4 divided by 6 minus 2 is 4. So that simplifies to -1. So that's my slope, but I want, that's the slope of line segment AB. So you can put AB if you want to help remember that that's the slope of AB. But I want its opposite reciprocal. So if I take 1 and get the reciprocal, that still gives me 1. But if I change the sign, that's going to give me +1. So the slope of the perpendicular is +1. So now I have the slope that I want, and I have the point that the line's going to be going through. So I have all the information I need to come up with the equation for line RS, which is the perpendicular bisector of segment AB. So I'm going to use point slope, y minus y1. And remember, the point I'm using is the midpoint, because that's where the line's going through. So y minus -1 equals M, we just said the slope of the perpendicular is 1 times x minus x1. And again, we're using this midpoint here, so 4. So when I simplify that, I'm getting y plus 1 equals 1 times x, the quantity x minus 4 is just x minus 4. Solving for y, subtracting 1. I'll subtract 1 from each side, so y equals x minus 5 is our equation for the perpendicular bisector. So it's equation for line RS.